Okay, peace be upon you all, and welcome to a new Finding Truth podcast with a very dear guest coming back to the channel, Dr. Hugh Ross. Hugh, how are you doing today?
Doing well, thank you.
So for those who don't know Dr. Hugh already, and if you don't, I really advise you to do. And you can start by actually looking at our previous interview, which was like a great one, generally about cosmology. This is how it looked. And it was a few weeks ago. And in that interview, which was generally about cosmology and faith, we also went into topics about our galaxy and the solar system and Earth and humanity and life. And well, we thought that deserves a topic of its own. So let me first just give you a little introduction, Hugh. So just for those who need to know, so Dr. Hugh Ross is the founder and president of Reasons to Believe, which is an organization that researches and communicates how discoveries about nature harmonize with the words of the Bible. And actually today we're also going to have some reflections about what cosmology tells us, and also to reflect about what the Bible and the Quran, from my side, also say about the topic. So his books include Weathering Climate Change, The Creator and the Cosmos, and Improbable Planet. All actually, and most specifically the last two, are very relevant to our discussion today. So Hugh, first, I hope you have had some great time with family in the vacations. Easter at your side, and actually Ramadan and Eid at my side. So I hope you're in very good health and just ready to give our audience some great information today.
Sounds great. I'm all set.
Yeah. So let's first see. So the title today is Milky Way and Earth. Spell God's name. So it's like I'm trying to give people some kind of a hint of what we're going to go through. But, the typical materialist view, and typically, materialists would like to hit at existential questions through questions primarily in astronomy and I guess in biology. So evolutionary theory on the biological aspect and maybe cosmic evolution. They like using the term evolution, I guess. And then origin of life, chemical evolution. So the thing is, it's like all a matter of luck. It's like luck striking here and there. Planet Earth is just, like this little speck of dust floating in a random place, in a random galaxy that has nothing special about it, that's floating in a random location in the cosmos. Where there are billions or hundreds of billions or maybe trillions of galaxies that look like it. And guess what? Life happened here, could have happened anywhere else, could have not happened anyway. And humanity and life and everything is just, a strike of luck. This is the view, and it just extends from the Big Bang until humanity. This is how it's portrayed. So my question to you, the opener one, is cosmology of our galaxy. Does the studying the astrophysics, the location of our galaxy, its history, have relevance to the questions of the existence of God and faith in general? What do you have to say about that one?
Well, Ahmed, last time I was on with you, we talked about how our universe contains what they estimate to be 2 trillion galaxies. So what's so special about our galaxy when you got 2 trillion in the observable universe? But last time we made the point, you can't get a galaxy like ours unless you got 2 trillion others. The total mass of the universe must be fine-tuned to get the elements in the periodic table that make life possible. Make the universe the tiniest bit bigger or smaller, there's no possibility for physical life. But to address your question, what's so special about our Milky Way galaxy? And a very timely question, because a paper got published in the scientific literature just days ago, answers this question to a degree I couldn't have told you about even 2 weeks ago.
And it's our luck then.
They took this first time ever survey of what are called subgiant stars. They actually accumulated a survey of 250,000 of these subgiant stars. whereas
Wow.
before all we had was a few thousand. So it's a
Oh.
much bigger survey. And the wonderful thing about subgiant stars, they're very accurate clocks. We can
Mm-hmm.
measure the characteristic of the star and determine when it was born in the history of the universe. And so
Okay.
they've accumulated this database of 250,000 subgiant stars in our galaxy. First of all, it reveals that our galaxy forms, one of the first galaxies to form in the history of the universe, literally
Wow.
formed when the universe was only about 800 million years old, which means
Wow.
our galaxy's been around for over 13 billion years.
Wow.
The
Wow.
most
Is this new information, or this has been common knowledge for some good time?
Well, it's been common knowledge that our galaxy's been around for 12 billion years. This now pushes it back to at least 13.1 billion years.
Wow.
And that's so early in the history of the universe. It's the time when galaxies of our size are forming for the first time. So it
Wow.
basically means our Milky Way galaxy is one of the first galaxies that appeared in the history of our universe. And
Wow.
the remarkable thing is it has stayed spiral throughout that whole time. Now,
Wow.
when the universe was young, over two-thirds of the galaxies were spiral galaxies. Today, only 6% are spiral.
Wow.
Spiral galaxies typically are not stable. When they get bumped by other galaxies, the spiral arm structure can collapse. And if the
Uh-huh.
galaxy isn't consuming dwarf galaxies, that will cease the stability of the spiral arm structure. So most
Uh-huh.
spiral galaxies collapse after a few billion years. And if
Oh.
they collapse and become spheroidal galaxies, the stars will now be too close together for advanced light to be possible. You don't
Uh-huh.
want to be around a star that's blasting you with deadly radiation, or a star
Okay.
whose gravity is going to disturb the planetary orbits. So,
So you made the comment that for life you need a spiral galaxy. Is it
right.
because you need the arms to be separated by things so that there is room for stability on our in our solar system so that our planet can enjoy best radiation? What are all the
Yeah, there are
reasons that
two
spiral
reasons.
galaxies are good for life? Yeah.
You want the stars to be relatively far apart. And
Uh-huh.
you only get that with spiral galaxies. You also want the star on which you're having your planet orbit far enough away from the supermassive black hole. All galaxies have supermassive black holes in their cores. At least
Mm-hmm.
all large galaxies do. And those supermassive black holes blast out deadly radiation. So you want your star to be orbiting far enough away where it's not going to be killed by that supermassive black hole, but you
Uh-huh.
don't want the star orbiting so far away that it won't have all the elements that it needs for advanced life. So
Mm-hmm.
our
Amazing.
sun is orbiting at the optimal distance from the center of our galaxy. And that's partly because we're in this large spiral galaxy that has remained stable for 13 billion years. It's
Wow.
one thing to get microbial life early. It takes a long time for the conditions to be prepared for advanced life. I mean,
Wow. Yeah.
I can share this with you. It's impossible to get advanced life in the universe in less than 13.8 billion years. We're here at the minimum time. But for
Wow.
that to be possible, we have to be in a large spiral galaxy that's remained spiral for those 13 billion years.
Hmm.
But there's even a bigger thing that came out of this paper,
Uh-huh.
and that is they were able to show number one, our galaxy's been consuming small dwarf galaxies on a highly regular, repetitive basis. That's
Mm-hmm.
important because the gas inflow from these small dwarf galaxies is crucial to sustain the spiral structure. If that were
Wow.
ever to stop, the spiral structure will collapse, which means we have to be in a cluster where there's a rich abundance of these small dwarf galaxies.
Wow.
That's the case of our local group. It's got two big galaxies, our galaxy and the local group. It's got five large spiral galaxies and about 200 tiny dwarf galaxies. Enough dwarf galaxies to sustain the spiral structure. On the other hand, if our Milky Way galaxy had absorbed a large dwarf galaxy any time in the past 10 billion years, that wouldn't necessarily rule out microbial life, but it would rule out life like us human beings. And this is what came through. We're looking at this study of 250,000 subgiant stars. They determined that the last time our Milky Way galaxy had a merger event with a large dwarf galaxy was 11 billion years ago.
Wow.
And it explained, and that ours is the only spiral galaxy that we astronomers have observed that has symmetrical, stable spiral arms without a lot of feathers and spurs between the arms. Those are all crucial requirements for advanced life. And I just put out a book about this. It's going to be released next month called Design to the Core. And in that book, I show you 15 large spiral galaxies that come the closest to matching the features of our Milky Way galaxy. And when you compare our Milky Way galaxy to these other 15, you see how different our Milky Way galaxy is. It's the only one with symmetrical spiral arms. It's the only one with the spiral arms just the right distance apart from one another. The only one that doesn't have a huge amount of feathers and spurs between the spiral arms. And so I don't know whether you've ever watched any of those Star Wars movies. They all begin with a little bit of script, a galaxy far, far away.
Yeah.
We astronomers have looked at galaxies far, far away. None of them are candidates.
Oh.
We need to change the script. It's got to be our galaxy. Galaxy.
It's this one. Don't look out there.
Yeah.
And now we also have the Webb and the James Webb telescope, and it's now getting its mirrors aligned, I guess, and we are able to look farther and farther every day. And what you're telling us is that the farther we look, it doesn't get any better. Only ours gets better, right?
Yeah, and we already know that. We don't even need the James Webb Space Telescope. And one of the problems in astronomy is the farther away you look, the farther back in time you see. So when you look at galaxies far, far away, you don't see them as they are now. You see them as they were 5 and 10 billion years ago. However, if we can examine in detail the structure of a galaxy 5 or 10 billion light years away, and therefore seeing it 5 and 10 billion years ago, we can predict what that galaxy looks like today. And so looking at the structure of a galaxy that's 5 billion years away from us, we can tell you what it's going to look like today. And what we can tell you is none of them are going to match the features of our Milky Way galaxy. It really is unique in the universe.
If I have even understood you correctly, you're telling me that entropically the spiral structure is at the low entropy side. So if a galaxy was less spiral 5 billion years ago, it means it's going to be even more less spiral now. It doesn't get better, right? It gets from spiral to spherical or to discoid kind of thing. So they are getting less in number, not more. If I understood you correctly, is that correct?
Yeah, and I'm looking at your background. Your background is a spiral galaxy M51 in Ursa Major, the Big Dipper. But if you actually look at the image in detail, you can see how the outer arms are significantly distorted. And even what I see just around your head there, you can see all the feathers and spurs between the spiral arms. And what's interesting, M51 is one of the galaxies that actually comes quite close to looking like our Milky Way galaxy. If you're actually to look at the whole image, you'll see there's another galaxy in the process of merging with M51.
That's correct. There's a small one at the rim. I noticed that one.
Right. Yeah. And look how it's distorting the spiral arms. Or you look at our sister spiral galaxy, the Andromeda galaxy. Same size as our Milky Way galaxy, but you can see where a dwarf galaxy has passed through the spiral arms about a 500 million years ago, and what it did to the spiral arm structure. Basically warped the spiral arm structure, distorted it, and wound up putting a bunch of stars far away from the center of the Andromeda galaxy. And so that's enough to tell us there's no advanced life in the Andromeda galaxy. And yet it's in the top 15 of the galaxies that come closest to matching our galaxy. Our Milky Way galaxy has no twin, at least no twin we've been able to discover to date. So we better take care of life here because we can't go to another galaxy.
So the good old, Noah's Ark spaceship where we're just gonna get out of the galaxy and find the new one is is like science fiction, yeah. It's either in this one or it's not there, or at least as far as we can see.
Well, that's my problem with watching Star Trek or Star Wars. They violate the laws of physics way too many times per minute for me to really enjoy it.
Okay, so they're still hoping for the warp drive to be invented, so they can, at least that part can go good. I'm not sure if it's gonna be actually.
A friend of mine who's the chairman of the physics department at Baylor University, he actually published a paper on what it would take to go faster than the velocity of light in a spaceship.
Okay.
You'd actually have to convert the entire mass of Jupiter in front of your spaceship into pure energy every second so that you can warp the space-time fabric and go faster than the velocity of light. And basically said there's not much of a chance of that ever being funded in the near future.
No. Doesn't look like so. So it's like an attempt to generate like a negative mass kind of propulsion system or something, right?
Well, the only way to go faster than the velocity of light is to distort the space-time fabric of the universe, and that takes an enormous amount of energy per second in order to make that possible. So we're not going faster than the velocity of light.
So you made this comment. Yes, there is like hundreds of billions or trillions of galaxies, but we need them so that we have one like ours. Can you elaborate on what that means? And also the matter of the elements, that we need specific elements.
Yeah, well, I think we covered this last time, is that the mass of the universe determines how rapidly it expands from the cosmic creation event. If you got more mass, it's going to expand more slowly. If you got less mass, it'll expand more rapidly. And the universe starts off infinitesimally small, but nearly infinitely hot. It's a principle of thermodynamics. The more you squeeze a system, the hotter it gets. Same principle of your car engine. When the piston chamber expands, the gasoline stops burning because it cools down. Well, that means that early in the history of the universe, it's cooling as it expands and spends about 20 seconds at a temperature range where nuclear fusion can occur, where hydrogen can be fused into helium. And if you make the universe slightly more massive than what it is, the universe will spend so much time in that temperature window that it will convert more than 24% of the primordial hydrogen into helium, and future stars will quickly convert all that hydrogen and helium into elements that are heavier than manganese, iron plus. But that would be a universe where you've got no carbon, no oxygen, no nitrogen, and no possibility for life. On the other hand, if you make the universe slightly less massive, the universe will spend so little time in that temperature window that you get very little hydrogen being fused into helium. And future stars will not be able to make any elements heavier than helium, which means you'd have a universe that forever is nothing but hydrogen and helium. And once again, life would be impossible. And to get it just right, so that you get all the elements we see in the periodic table, the total mass of the universe has to be fine-tuned to within one part in a quadrillion, 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 quadrillion. It's one of our most potent evidences for supernatural design. because that's way beyond any design that we humans are able to achieve. So
Hmm.
someone a lot more intelligent, a lot more knowledgeable and powerful than us human beings must have created the universe.
So this is very relevant to the matter of that the entropy of the universe at its beginning was so well fine tuned to an amazing extent. Is this true?
Yes, and I'm making the argument assuming that matter is the only factor governing the expansion of the universe. We
Hmm.
now know there's a second factor called dark energy,
Yeah.
which actually accelerates the space-time fabric. And
Hmm.
that
Hmm.
actually lowers the amount of fine tuning you need for the mass of the universe. Is no longer 1 part in 10 to the 60th. You can drop it down to about 1 part in 10 to the 50th. The problem is the fine tuning in dark energy goes up to 1 part in 10 to the 122nd place. That's
Wow.
21 zeros between the decimal point and the one.
Wow.
And so this is where we get the most spectacular, measurable evidence for fine tuned design to make life possible in the universe. And so, with a universe that massive, you will have 2 trillion galaxies in the universe. But
Hmm.
as we look at the universe, we notice that these galaxies are grouped together into superclusters of galaxies, which is a cluster of clusters of galaxies. But something I'm putting in my new book, Beyond the Cosmos, is that we've now seen tens of thousands of these superclusters of galaxies, but we live in a unique supercluster. These
Okay.
other superclusters are kind of like basketball shaped, where
Hmm.
all these clusters of galaxies are kind of jammed together in a spherical configuration or an ellipsoidal configuration. We live in the Laniakea super galaxy cluster, which has
Okay.
a unique shape. It
Hmm.
looks like a stick insect. So think of a praying mantis. So you
Oh.
got these clusters of galaxies strung along these long filaments. That's
Okay.
crucial because it means it's possible to have a site within that super galaxy cluster where there's no nearby supermassive black holes radiating deadly radiation that's going to wipe
Wow.
out life. I mean,
Wow.
that's not going to happen in the other super galaxy clusters, but it can happen. So we live in the one and only super galaxy cluster where advanced life is possible. We also live in the one and only galaxy cluster where advanced life is possible, and the
Wow.
one and only local grouping of galaxies where advanced life is possible. And what we just talked about, we live in the only galaxy where advanced life is possible. And so
Wow.
we're discovering that when we look for twins of our Milky Way galaxy, we can't find any. We look
Hmm.
for twins of our star, we can't find any. Our star, the sun, is the only star out of tens of millions that we've measured that has the characteristics that allow a planet to orbit it on which advanced life is possible.
Wow. We're gonna come to the solar system. So what you've just told us is, I've talked to many atheists and people who have doubts, and they would give you this argument. God, according to our description as people who believe, is the wise, and how can a wise God create such a huge cosmos just to use this little speck of it, and the rest is useless? And the story you've just told us is that you need the crown to put the crown jewel on it, and the crown might be quite big, but it's there to manifest or to demonstrate the beauty of the little jewel that's sitting at the center. So would
Yeah,
that be
well,
a good depiction?
also, the atheist is overlooking a crucial factor here.
Hmm.
God's got more than one purpose for making the universe the way he did. He
Hmm.
not only created it to be a pleasant home for us human beings, his real goal was to use the universe as a tool to eradicate evil and suffering once and for all. This is something you see in multiple places in the Bible that before God began his works of creation, he initiated his works of redemption. So the ultimate purpose for God making the universe the way it is to use it to permanently eradicate all evil and suffering. That requires a universe with thermodynamics, with gravity, with electromagnetism. It also requires a universe to be the size and the age and the mass that it is. So, and in one of my books, Why the Universe the Way It Is, I outlined 12 different purposes for why God made the universe the way he did. And so it explains why, hey, you have to have a universe with 2 trillion galaxies, where those 2 trillion galaxies only make up 0.25% of all the material reality of the universe. Everything has to be fine-tuned. If you want to simultaneously create a home where billions of humans can live on one planet and launch and sustain advanced civilization and technology, which is crucial to take the good news of redemption to all the people groups of the world. So that's why the universe must be precisely the way it is. God doesn't just have one reason for designing the universe the way he did. He's got multiple reasons. I mean, a good analogy would be you want to buy a car and you want good gas mileage, but you also want good performance. Well, if you want to have both good performance and good gas mileage and a comfortable interior, it really requires that your automobile be exceptionally fine-tuned. And so you wouldn't need to have a comfortable automobile if all you cared about was gas mileage. But if you want to have all these multiple purposes fulfilled, then it really does constrain the properties of the automobile. And to a much greater degree, that's true of our universe and our galaxy.
So an insight from that, and also getting some glimpses of also what the Quran is saying, because in the Quran there is an insistence that the cosmos is pretty well suited to the human being, not just the Earth. So he goes like هو الذي خلق لكم ما في الأرض جميعا ثم استوى إلى السماء فسواهن سبع سماوات. He has created for you all that is on earth, and he directed his attention to the heavens, and he proportioned them into 7 heavens. So he's relating the fact that an objective is the existence of humanity, but that the heavens, and the heavens includes our cosmos, is like engineered to serve this purpose. So it's what you're saying about how all of this adds up, that the trillions of the galaxies and the vastness of the cosmos and the structure of the superclusters and the shapes, all at the end boil down to making this little speck. Not actually a little speck. It is like the very small chip in the very small piece of plastic that sits in the core of a huge supercomputer that needs 10 miles of power generation and cooling and power lines and sewage and security, and there's this very little processor that is weighs 10 grams that's running the whole show. This is from my from my discipline. And then somebody says, whoa, how come all of this huge complex with this nuclear reactor powering it just for this little processor? It must be a coincidence. But it's the other way around. It's important things come in little packages, it seems. But they need so much around them to serve them.
A core doctrine of Christianity is that God gave us 2 books, the book of nature and the book of scripture. And what really encourages me as an astronomer is to discover that we human beings are living on a planet that's here at precisely the right time and in the right location, so we astronomers can measure and observe the entire history of the universe. So, for example, if God put us here 5 billion years earlier, we'd only be able to see the last 2/3 of the history of the universe. If you put us here 5 billion years in the future, we'd only be able to see the last 2/3 of the history of the universe. He put us here precisely the right time. And I've got a chapter in Why the Universe is the Way It Is, explaining if we were anywhere else within our Milky Way galaxy, we wouldn't be able to see the whole history of the universe. If we were anywhere else in our solar system, we wouldn't be able to see it. And if our Milky Way galaxy were in any other location in the Laniakea supercluster, we wouldn't be able to see the whole history of the universe. We're simultaneously at precisely the unique location and the unique time when we can read the whole book of nature from now until the very beginning of creation. And it's our ability as astronomers to directly witness the cosmic creation event where we get the most compelling and rigorous scientific evidence that a God beyond space and time must have created all this for our specific benefit.
When you're talking about the location of our cluster and our supercluster and our galaxy, can you give a statement about where is actually the Milky Way in comparison to, let's say, the observable universe, since this is all what we can know? So if the observable universe is like a sphere, as far as we're concerned, where do we sit in that sphere?
Well, I can tell you that we're in this enormous supercluster of galaxies, a cluster of galaxies. But our local group is on a subfilament of that supercluster where we're really far away from the Virgo cluster. That's one of the larger clusters of galaxies in the Laniakea supercluster.
Mm-hmm.
If we were any closer, the light from that cluster of galaxies would make it very challenging to do astronomy. The night sky would be just too bright. And there are darker spots where we could be, where we could get a better view, but those darker spots are places where advanced life is not possible, where it's not possible of a spiral galaxy. We happen to be living in the one location along the subfilament of the Laniakea supercluster in a grouping of galaxies. When you look at our local group, it's the one grouping of galaxies that has no giant galaxies. Put a giant galaxy in our group, it would cause parts of the sky to be too bright to do deep sky astronomy. We have no giant galaxies. There's only one other large galaxy in the local group. That's the Andromeda galaxy. Now, it does block out a small patch of the sky, but only a small patch. The rest of the sky we get to see. And
so we are like sitting on an observatory on our planet.
We're sitting on the ideal observatory in the universe to be able to see all the details of the universe, and in discovering those details to realize, wow, the God of the Bible is the one that created all this and designed it for our benefit. There really is a God beyond space and time. I mean, we were able to make observations that led to the discovery, the space-time theorems. And so space-time theorems that prove that a personal causal agent beyond space and time created the entire universe. So God put us in a place to make these amazing discoveries. And I think he chose us to be alive in the 21st century. It's the 21st century where we're seeing revelation from the book of nature like humanity has never seen before.
Yeah. And it also reminds me of this verse. It says, walk the earth and look how creation has started. And another one that says, we will show them our signs in the horizons and within themselves until it's evident to them that it is the truth. And in my reading, in the horizons is as far as you can look. And what you're telling us is that we are in the best place so that we can look as far as possible, because it's quite dark and nice to look through.
Well, so if we were anywhere else within our Milky Way galaxy, if our galaxy were anywhere else in the Laniakea supercluster, there'd be no need to send up the James Webb Space Telescope, because it wouldn't be able to see what we wanted it to see anyway. But the James Webb Space Telescope has the power to actually image individual stars that were forming in the first 200 million years after the cosmic creation event. And once that data comes back to us, we're going to have even more potent evidence for the Big Bang creation event. And what I find significant about Big Bang cosmology, thousands of years ago, you got 6 authors in the Old Testament that wrote about the 4 fundamental features of Big Bang cosmology. Space-time beginning, expands from that space-time beginning under laws of physics that never change, where one of those laws is a pervasive law of decay. And what I find remarkable about the Old Testament, it states those 4 features of the universe very explicitly and repeatedly, not just once or twice, but literally dozens of times each.
Wow. It takes me to the maybe to the our little backyard, the solar system within this galaxy. So again, one of the arguments is, oh, even look at the Milky Way; it has billions of stars, and don't know how many 100 billion or even
400
more.
billion, that's all.
400 billion. Wow, that's quite a lot. And the sun, and it's just another star and everything. And you're telling us it's not actually true. So what's special about our solar system in terms of its location, its constitution, its star?
Well, for 60 years, my astronomy peers have been scouring our galaxy and the Andromeda galaxy in search of a star that's sufficiently like the sun that it could be a candidate to have a planet orbiting it on which advanced life exists. And for that to be possible, that star has to be the same type and age of the sun.
Mm-hmm.
Only G25 stars that are 4.57 billion years old will have the luminosity stability and the lack of flaring activity that advanced civilization needs.
Wow.
And the best candidate we have found is a star that has a luminosity instability 5 times greater than the sun.
Wow.
If that was the case, we wouldn't be able to live on a planet orbiting that star. Now, the search is still going on, but we've already scoured tens of millions of stars. None of them have the appropriate characteristics that our sun has. It's got a unique abundance of elements. We've yet to find a star that's got the abundance of elements that the sun has. And in my next book that's coming out next month, I explain why. It's because the sun experienced an event early in its history when it was in a dense cluster of stars, whereby it transferred a lot of its heavy elements and angular momentum to the emerging rocky planets. And this is something we've discovered. We've now found 5,000 planets orbiting stars beyond our solar system, and hundreds of rocky planets. But none of those rocky planet systems are like our suns. What we're seeing in other stars, yes, they've got rocky planets, but they orbit much closer to their host stars. And they're not as dense as our rocky system planets, as our solar system's rocky planets, and they're not as big. Unique to our solar system is we have these large rocky planets orbiting relatively far away from the host star. And it's this transfer of angular momentum and heavy elements from the sun to its emerging rocky planets that made that possible. While also Jupiter, Saturn, Uranus, and Neptune also play a crucial role in making sure, for example, that Mars is not too big. Because what we're seeing in other planetary systems, the rocky planets get bigger and bigger as you move away from the star. And that's the case for Mercury, Venus, and Earth. But look how tiny Mars is.
Yeah.
For 20 years, astrophysicists have been trying to solve what they call the small Mars problem. Why Mars is as small as it is, and not it's the mass of Earth. And it's all because our solar system was born with 10 planets, 5 rocky planets, and 5 gas giant planets. One of those rocky planets merged with the Earth and made the Earth bigger and denser, and also led to the formation of the moon. And so notice Earth is a relatively small planet with a single gigantic moon orbiting it. And that's actually crucial for advanced life. And so that merger event made that possible. But likewise, we've got 5 gas giants. And what happened was Jupiter and Saturn were migrating towards the sun, stopped, and reversed direction and migrated outwards.
Wow.
We don't see that in any other planetary system. It's unique to our solar system, but it's that moving forward, stopping, and moving backward that resulted in one of the gas giants being ejected out of the solar system, the smallest of the 5, and Mars becoming a tiny planet instead of a big planet. And so I remember in 1995 when astronomers discovered the first planets orbiting other stars. And they were saying, we're going to find thousands of planets and they're going to be just like the planets in our solar system.
Yeah.
Well, here we are, a quarter of a century later. We've got discovered 5,000 of these planets. Not a single one is like any of the 8 planets in our solar system. And that
Yeah.
led to an amazing discovery, namely that the characteristic features of every one of the 8 planets in our solar system are crucial to make advanced life possible here on Earth. So
Oh,
it's
wow.
not just the Earth that has to be designed, Mars has to be designed, Uranus, Neptune, Mercury, Venus, they all have to be exquisitely designed for advanced life to be possible here on planet Earth.
Wow. I have read a little bit about how Jupiter and the this belt. I can't remember the name of the belt.
The
Alcubierre, you
asteroid
think?
belts.
Yeah, the asteroid belts. Yeah, and how it's guarding. It's like moving around like a watchdog, and it's preventing Earth from being bombarded by huge asteroids and getting destroyed.
Right.
It's like our guard. And I thought it's something about only Jupiter has a specific function related to Earth, but you're telling me it's even all the others also have it.
Yeah, Jupiter plays the most critical role in ensuring that planet Earth doesn't get bombarded too frequently by big asteroids and comets because it's a massive body. Notice it's the most massive of the gas giants and it's the
Yeah,
closest to the Earth. So
yeah,
it fulfills a role. But in order to ensure that we get the just right bombardment history, it's important that Jupiter be the closest to us and the most massive. It's also important that the shielding be distributed amongst 4 gas giants, not just one. So if it was
uh-huh,
just Jupiter by itself, we'd be in trouble. And you need a shield whereby the second most significant factor would be a planet that's the next most massive and the next closest to the Earth. That's Saturn. And so
uh-huh.
Saturn has to have the features, and the orbits of the 4 gas giants have to be fine tuned for that shielding to work. And you
Wow.
don't want the shielding to be too good. So it'd be bad if, for example, we didn't get any collision events.
Yeah.
So, for example, we lose a little bit of water to outer space. It happens slowly, but water is escaping to outer space.
Yeah.
But that water that we're losing gets replaced by comets. We get bombarded by about 10,000 mini comets every day.
Mm-hmm.
Comets are about 85% frozen water. So the water we lose is replaced by the water we gain. It's also important that we get the occasional large asteroid colliding with the Earth. So, for example, there's an asteroid that collided on the north shore of Lake Superior. And it's one of these asteroids that's virtually pure stainless steel. Uh,
Wow.
it's iron and nickel and cobalt. Well, 50% of the nickel that's in industrial circulation today comes from that asteroid on the north shore of Lake Superior.
50%. Wow.
50%. And
Yeah,
likewise,
it saved the industry for sure.
yeah, it changed the industry. And probably a more famous example is the asteroid that struck in South Africa, just outside of Johannesburg.
Okay.
That asteroid is responsible for 80% of the gold that's in circulation. And so,
Wow. The
uh,
gold.
yeah. So, I mean, and the platinum metals, that all comes from that one asteroid.
Wow, lucky them.
There's actually asteroids out there that are almost pure platinum, gold, osmium. And in fact, NASA actually has a plan to go out and capture one of those asteroids and mine it, because those are really valuable metals. But hey,
Is it true that a good part of the iron cobalt core of the Earth could have been acquired from comet collisions back in the
yeah,
deep
part
history
of
of
it did
Earth?
come from that.
Hmm.
Part of it came from the merger of the planet Theia with the proto-Earth. The moon forming event played a role. The moon actually plays a role in shepherding these dense asteroids towards the Earth to ensure we get the right delivery.
Yeah.
And so we need asteroid and comet belts to be fine-tuned. For example, our solar system has 5 asteroid and comet belts, and they're all just the right size, just the right distribution and distance to ensure we get the right delivery of water and the right delivery of these valuable metals without having so frequent collisions that it make it impossible for us to live in cities.
Wow.
What I'm writing
Amazing.
about in my next book is that we astronomers now have the capability to detect asteroid and comet belts around other stars. And we're finding that 80% of them have no asteroid and comet belts at all.
Oh,
And that's because
8%.
80%. And that's because their gas giant planets have migrated in towards the host stars and stopped, but did not go back. And so
Oh,
they came in, and they came in much closer than what
oh,
Jupiter and Saturn did. And it was that movement that eradicated all the asteroid and comet belts.
oh.
The other
They,
20%,
they they cleaned it up. They cleaned it up completely.
yeah, by that migration wiped them all out. The
Oh,
other 20%, the gas giant planets don't move inward. They either stay put or they go outward. And what happens is you wind up retaining the asteroid and comet belts in their primordial form. So what we're discovering is those stars have asteroid and comet belts that are thousands of times bigger than we see orbiting the sun, which means the bombardment
it's
frequency is going to be very intense.
huge. Wow.
And so we're living on the only planetary system where the asteroid and comet belts are exactly the right size and the distance to ensure we get the just right delivery without being wiped out by the delivery process.
Wow. And is there an explanation for this moving in, stopping, and then moving out? Do we
Yes,
know what
there
caused
is.
them to do that? Yeah.
What caused that to do that is the reason why they move inward, the planets form without eliminating all the gas and planetesimals in their vicinity. And it's a gravitational interaction of the young gas giant planet with the remaining gas and planetesimals that causes it to move inward. And when all the gas and planetesimals are exhausted, it stops.
Uh-huh.
But what happened in our solar system is that Saturn migrated in more rapidly than Jupiter did,
Okay.
because Saturn was residing in a place where there was a greater density of this gas and planetesimals. So it moved at a faster rate, and it reached a point where Jupiter was making 2 orbits of the sun for exactly every 3 orbits of Saturn.
Okay.
Pardon me, the other way around. Jupiter was making 3 orbits for every 2 orbits of Saturn.
All right.
And that set up what's called a 2-3 mean motion resonance. And it was
Okay.
that resonance that caused these 2 planets to change direction. They stopped and then moved outward. So it's
Wow.
that mean motion resonance that caused that to happen. And when that happened, it also caused Uranus and Neptune to migrate outward. Neptune migrated outward from about 10 astronomical units to 30 astronomical units.
Wow.
And what that did is it stripped down the outer asteroid and comet belts. They were hundreds of times bigger before Neptune made its migration into the outer part of the solar system. And so it made those comet and asteroid belts just the right size. If it wasn't for
Wow.
Neptune being kicked out like that by the movements of Jupiter and Saturn, then those asteroid belts would be too big and we'd be bombarded too frequently. We'd be getting too much water. Too much water is as big of a problem as too little water, because now
Yeah.
you would have deep oceans and no continental land masses.
Wow. And while listening to you, I'm thinking, what are the odds? What in the universe are the odds of all this alignment of good luck events can actually reasonably happen if they're not
Well,
designed?
this is referred to in the scientific literature as the grand tack model, because it's like in
Okay.
sailing, where you change the sails to reverse direction. And so kind of the wind from the gas and the planetesimals cause the gas giants to change direction. But yeah, the people who have worked on this model, they've been working on it for a quarter of a century. They're saying it's likely that our sun is the only one that's had a set of planets where the gas giants experience
Wow.
this precise reverse in direction. And then
Wow.
a paper just got published a few months ago saying that, when we look at the moon, we now recognize if the moon didn't form exactly the way it did, and with the migration history, because the moon is basically spiraling away from the Earth, that if that wasn't happening, there'd be no advanced life possible on the Earth. And it's based on the recognition that, this planet Theia merged with a proto-Earth,
Mm-hmm.
formed the moon, and the Earth was rotating very rapidly as a result of that event, and the moon was really close to the Earth. And because of the merger, both the core of the Earth and the core of the moon at that time were very hot.
Uh-huh.
So hot that you had a liquid iron nickel core in both bodies.
Mm-hmm.
And they were close enough together that the tidal forces that the moon exerted on the Earth circulated that liquid nickel iron core. And
Okay.
you're an electrical engineer. You know
Yeah.
that it's not enough just to have liquid iron. You have to
Yeah.
circulate it to get a dynamo. And
Yeah.
without the dynamo effect, you're not going to get a magnetic field.
Absolutely.
But what we now realize is that just like the tidal forces of the moon on the Earth circulated the liquid iron in the core of the Earth, likewise the tidal forces of the Earth exerted on the moon circulated the liquid iron in the core of the moon, and the bodies were close enough together that their magnetospheres merged. And so you have this coupled magnetosphere, and this all happened at a time when the sun's particle radiation and flaring activity was 10,000 times greater than today.
Wow.
It
So
wasn't for that.
we needed plenty of shield.
We did, well, that only happens for the first 400 billion years of the sun's history, first half billion years.
Yeah.
That's when the sun is pouring out this intense particle radiation. And but thanks to the moon's magnetic field coupling with our magnetic field, we had an adequate shield, and that shield prevented those solar particles from sputtering away all of our atmosphere and sputtering away all of our liquid water. If it wasn't for the moon having a magnetic field that coupled with ours in the first half billion years of the history of the solar system, Earth would be bone dry with no atmosphere and no possibility for life.
Wow.
And
Wow. That's
the astronomers who wrote this paper, none of them are believers, but they said the only way you're going to have a habitable planet is if you have a planet, a rocky planet like the Earth, a moon like our moon, with this hot liquid iron core where the magnetospheres couple to a sufficient degree to prevent the host star from sputtering away all the atmosphere and all the water. Now,
wow.
the
Amazing.
probability of that happening by chance is so utterly remote that even in a universe with a trillion stars, the probability of that happening by chance is way less than one chance in a quadrillion, 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 quadrillion.
Wow. Amazing. I'm just remembering this verse. It says, وَجَعَلْنَا الشَّمْسَ وَالْقَمَرَ آيَتَيْنِ. We have made the sun and the moon as two signs. And the relation between the sun, the moon, and the earth that you're describing is just so mind-blowing. It also grabs my attention that the distance of the moon from the earth versus the distance of the earth and the sun make, earth and sun and moon make the moon look apparently the same size of the sun, and this makes eclipses, for example, possible. And
Right.
and the fact that the moon is locked to the extent that just one face of it is just looking at us all the time, this face drawn on the moon, and just the fact that the moon is like 1/400 of the sun's size or something, and it's 1/400 of the distance. So it apparently looks exactly the same, almost exactly the same size of the sun, just allowing for this small, silver lining in the eclipse. Is there a scientific explanation for this?
There is, but it's another example of fine tuning because, the formation of the moon through the merger of these two planets, the Earth was rotating about once every 2 hours, so at a very rapid rotation rate. And the moon began to spiral away from the Earth. And so, but it's continuing to exert tidal forces on the Earth, and those tidal forces gradually slow down the rotation rate. So today, 24 hours a day. And, primitive life can handle a rotation rate of 15 hours a day, but not human beings. If it was 23 hours a day, we'd be in trouble. If it was 25 hours a day, we'd be in trouble. We need it to be 24 hours. Because the problem when you make it 25 hours, the temperature differences between day and night become too great. If you make it 23 hours, you don't get the rainfall distribution over all of the continental land masses. So you got a very limited place where humans can live. 24 is optimal. And so we got the moon spiraling away, and we hit 24 hours per day at just the time when you get these perfect solar eclipses. And so we're in a narrow window of time, because in the future, as the moon spirals away from the Earth, you'll no longer get solar eclipses. There'll be an annulus around the moon. And so you won't be able to see the corona. You won't be able to test theories of general relativity like we can today.
Yeah.
And notice each eclipse is a little different. I saw the eclipse in 2017 where the eclipse only lasted 2 minutes. And that's because the moon's diameter and the sun's diameter were almost identical, which allowed you to see the corona out to 10 moon diameters away from the sun.
Wow.
But the eclipse is going to happen in 2024. That's going to be 4.5 minutes. And with that eclipse, where you got the moon a little bit bigger than the diameter of the Earth, it gets completely dark, and you'll be able to see stars close to the limit of the sun and be able to observe those stars to test theories of gravity. So it's like God put us here at a time when we can do all this observations, and we're here at the only time where that is possible. And also we hit that 24 hours a day at the same time the sun reached its minimum flaring activity and its maximum luminosity stability. And that's a narrow time window. It's only a few 100,000 years wide. And so we got the moon spiraling away from the Earth, making us hit 24 hours a day at the optimal time when the sun has the conditions that makes our existence possible, where we also get perfect solar eclipses so we can do some amazing astrophysical discoveries.
Wow. This is so... actually, I didn't prepare the question, but your answer to the question is striking me so hard, because the rest of the verse says, وَجَعَلْنَا اللَّيْلَ وَالنَّهَارَ آيَتَيْنِ فَمَحَوْنَا anyway, so it's the relation between the number of years exactly when this event has taken place, the 24-hour thing, its relation to the length of the day and the night and the very existence of humanity at that point, and the relation between that and between other sciences, that is striking to me. Yeah.
Well, it even is a factor for the mammals and birds on the Earth, because right now the moon is at just the right distance from the Earth, where you get a particular illumination of the night sky on a monthly cycle. And I've written an article on our reasons.org website where I explain that's optimal for mammal species on the continents, that they have the moon with that just right illumination during the night, so that you can have the maximum number of mammal and bird species on the face of the Earth. That's part of what we notice with life. We humans are here on planet Earth when the biodiversity is at the physical maximum. And that's the only time in the history of the Earth where it's been at the maximum. We're right here at that time.
Yeah. The one verse that I wanted to is الشمس والقمر بحسبان. It means the sun and the moon are with great calculation. This is what the translation of meaning means. The sun and the moon are with great calculation. So yeah, amazing. I have been reading something lately about a bubble, a local bubble that the solar system is sitting in.
Yes.
The way I understood is that this bubble is a bubble inside the Milky Way, other than the sort of void with the Milky Way, or comfortable dark space that the Milky Way is sitting in. But there is like this almost spherical or spheroidal bubble that the solar system is in. Can you tell us something about that? And
yeah, I devote a whole chapter to that in my book, Design to the Core, is coming out next month, making the point that when you look inside our Milky Way galaxy, our solar system is situated on the just right tiny, what we call the local arm, that's in between the Sagittarius and Perseus spiral arms. And we're in a location where we're halfway between the Perseus and Sagittarius spiral arms, where there's no nearby black holes that are radiating deadly radiation, and there's no nearby giant molecular clouds, which would both be problems for advanced life. And in that particular location, we are in what's called the local bubble. Now, there's lots of bubbles in our Milky Way galaxy, but we happen to be living in a bubble that is fine-tuned to make advanced life possible. That's not the case for the other bubbles. We're living in the one and only bubble. And inside that local bubble is a region called the local fluff. And that local fluff likewise is fine-tuned to make our existence possible. And then we're in this unique planetary system. Now, kind of the point I'm making in the book, no matter what cosmic size scale you look at, the universe as a whole, you could look at the cosmic web, which is that structure of super galaxy clusters. Our super galaxy cluster, our cluster of galaxies, the local group, the galaxy, the local spiral arm region, the local bubble, the local fluff, our star, the planets that orbit our star, the comet and asteroid belts, and then even when you dig into the interior of the sun and the earth, no matter what size scale you look at, you will discover overwhelming scientific evidence for the creator God of the Bible, fine-tuning everything just right so that billions of us human beings can live on planet Earth at one time with the technology to take the good news of redemption to all the people groups of the world.
What can be a materialist explanation for this local bubble? And
well, they will argue it's all just a coincidence. And I'm saying, well, I could handle one scientific coincidence, but when we look at hundreds that all have to be fine-tuned for these purposes to make possible the existence of billions of humans on this planet, it can't be just a product of pure chance. And what I've been sharing lately with my secular peers is saying, look, I know you don't believe in God, but if you will simply do your scientific research from a biblical redemptive perspective, from the perspective of a God designing the universe to redeem human beings from their sin and evil, I think it'll make you a better scientist. It'll make you
Mm-hmm.
more successful in making scientific discoveries. And I'm saying, just try it and see what happens. And of course, my real motivation is when they see that it makes them more successful, they're going to say, you know what, maybe I need to change my philosophy and actually give serious attention to this idea that there's a personal creator who designed the universe to redeem me from my propensity to commit sin and evil and to take me into a new creation where evil will never happen again.
Actually, I had a question about what would be your advice to young astronomers. So you,
I kind of gave you the advice already, right?
yeah, that was it. So this plateau that we're living on, this theater called Planet Earth, uh, is there something special about it as a planet that you have not mentioned while talking about the cosmic web, the cluster, the galaxy, and the solar system? Um, what makes Earth what makes Earth the little blue jewel it is? Is there something really special about it?
Oh, yes, there is. You mentioned earlier my book, Improbable Planet. That's the book that reviews some of the highlights.
Mm-hmm.
And you don't have to buy the book. You can go to our website, reasons.org/fine tuning. That will
Okay.
pop up for you a 300-page compendium. We're
Wow.
making it available for free, and it documents all the scientific papers published that establish that hundreds of features of planet Earth have to be exquisitely fine-tuned to make advanced life possible on the Earth. And that compendium documents over 400 distinct features of
Wow.
our Earth that must be fine tuned to make our existence possible. And we actually calculate the probability that you'd be able to find a body like that anywhere within the entire universe without invoking divine miraculous intervention. And the probability at this point ranks less than one chance in 10 to the 1050th power. And well, you know how big that number is. What I try to do for people who don't have a degree in electrical engineering is
Yeah.
basically say that's roughly equivalent, and I'll use an American analogy, to winning the California lottery 150 consecutive times, where you buy only one ticket each time.
Wow.
Or as a
Okay.
mathematician friend of mine told me, it's no different than the probability of winning the California lottery 150 consecutive times where you don't buy any tickets at all.
Okay. That's a good one.
So, yeah,
Okay.
even if all you look at is planet Earth, you get an overwhelming case that it's a product of supernatural, super intelligent design. I mean,
Yeah.
just to give you a couple of examples, we live on a planet that has both surface continents and surface oceans. And we astronomers are now finding Earth like planets orbiting other stars. And what we're discovering is they got about 500 to 1,000 times as much water as our planet Earth has, and
Wow.
more than 1,000 times as much carbon. Now,
Wow.
carbon is crucial for life, and so is water. But too much carbon is a problem. Too much water is a problem. With 500 times as much water, you will get frozen water on the surface when it gets cold enough, but you actually get another state of frozen water. If you take liquid water and put it under high pressure, no matter what the temperature of that liquid water, it'll be frozen on the bottom,
Wow.
which means for those planets, you're going to have a permanent ice layer that separates the water from the interior rock, which
Mm-hmm.
eliminates any possibility for life. You have to have some contact between the rock and the water. For Earth, that doesn't happen. And what we're seeing is we're finding Earth-like planets that have no water at all. They're bone dry, or they got way too much water. Our planet has just the right amount of water and has just the right amount of atmosphere. And we talked earlier about Theia and the proto-Earth merging. Earth began with about 1,000 times as much water as it has today, and an atmosphere 200 times thicker. And that's what you'd expect. The farther away a planet is from its host star, the thicker the atmosphere and the greater the water. I mean, Venus has an atmosphere 90 times thicker than the present day Earth. Earth would have started off with an atmosphere 200 times thicker. But that merger event caused the proto-Earth to lose virtually all of its atmosphere and all of its water. But enough remained at just the right level to make advanced life possible here on planet Earth. And we've already discussed the coupled magnetosphere. And the amazing thing is when the moon being smaller, its liquid core cooled off a lot faster. So within 500 million years, it lost its magnetic field. But by that time, Earth's much larger liquid core also began to cool. And so you had a frozen solid core surrounded by a liquid core. And it was that solid core surrounded by a liquid core that caused light elements to be squeezed out of the inner core into the outer core, and that caused it to circulate. So when the moon moved too far away for its gravity to circulate that liquid iron core, the newly formed solid core in the interior Earth ensured that that circulation would continue. And because of how massive the Earth is, and the fact that it's got 630 times as much thorium and 340 times as much uranium as any other known rocky body.
So the radiation decay would keep heating it.
Yeah, it keeps it warm enough that today we still have a liquid iron core surrounding that solid core. And so for 4.5 billion years, Earth has had a strong enough magnetic field to protect us from deadly solar radiation and deadly cosmic radiation.
So what you're saying is that there is also fine tuning concerning the amount of radioactive material that we have on our crust.
Exactly.
That keeps on heating the core so it doesn't just solidify.
Right. And not so much that it would be a problem for us. You don't want to be around a lot of uranium.
Yeah.
But you need enough to keep the plate tectonics going and the magnetic field retaining. So that's 3 examples out of the 450 that are on that reasons.org/fine tuning.
Wow,
so, yeah,
450.
It's a mind blower when you look at it all.
Wow, yeah, amazing. That's really amazing. Hugh, I'll give you this last question, and then we can take some questions and answers from the audience. What if just said, and also you said it's not everything. How does this fit to the materialist view that Earth life and humanity is a coincidence? And I'll add to that. Sometime you'll tell them all of those issues, and that what they're going to say, well, maybe there is another kind of life that can be possible under different conditions that we cannot imagine. Maybe there is, I don't know, life that is not carbon-based, or life that is carbon-based but looks different. Yeah?
In a debate I had with the atheist particle physicist Victor Stenger.
Okay.
Here in America, we got a group called the International Skeptic Society. It's a worldwide organization of atheist engineers and scientists. Mm-hmm. And so they had their conference at Caltech, and they invited me to debate Victor Stenger on whether or not science shows the evidence for God. Mm-hmm. And Victor Stenger's point was, well, Hugh, I accept all this fine tuning for us, but what about life that's not like us? What about life that's not carbon-based? And I kind of joked with him and said, oh, you must be referring to the angels. Uh, they're, they're
Good
intelligent,
one.
but they're not constrained by the physics of the universe. And so,
Absolutely.
yeah, they don't have to be built and designed on the elements in the periodic table. But in response to his suggestion, maybe it
Okay.
doesn't have to be carbon based. I said, hey, that was solved 35 years ago.
Mhm.
As chemists have looked at the periodic table and realized there are elements that do permit chemical complexity that life needs, such as silicon, such as arsenic, such as boron. But in every single case, you do not get the bonding stability or the bonding complexity that you get from carbon. If there's physical life in the universe, it must be carbon based. I don't care how many eyes it has, but it's got to be carbon based.
Yeah,
And
that has to
Victor
be.
kind of joked with me and said, "Yeah,
Yeah.
I guess if you're going to talk about beings that are not constrained by the physics of the universe, they're going to have different fine tuning." And by the way, that debate is still available if people want to watch it. They
Yeah.
can buy it from the Skeptic Society for $30. We sell it for $5 because we want you to see it.
All right. Okay. Interesting. Interesting. I guess they're buying it so high because they don't want anyone to see it, actually. Maybe. I
Well,
don't know.
$30 is not a big price, but yeah,
Yeah.
I mean, when I was talking to the atheists afterwards, they said we have never heard a scientific defense of the Christian faith in our entire life. This is the first time we've heard a credible. I mean, all they've been exposed to is young Earth creationism, and young Earth creationism exists in both Islam and in Christianity, but neither the Quran nor the Bible supports that interpretation, and certainly the science doesn't. But I'm
Yeah.
amazed how often atheists will bring that up as a straw man and say, there is no God out there. So I had
Yeah.
a chance to just share them. This is what the Bible really teaches, and this is what the science says. But yeah, it shocked me that that audience of 800 atheists, that was the first time they'd ever heard a credible scientific defense of the Christian faith.
So it tells something if even the answer to this question, because even when I've heard some atheists talking about maybe there's a different way of life to exist beyond carbon, and I didn't even hear somebody talking about life that can exist without water, for example, etc. But
Sure.
then, so it's you need carbon and water and the atmosphere and proper distance from a sun or a star, etc., etc., etc. And they know all of this, but they just throw to the layman or to the layperson that you don't need to worry about it. There are so many trillions of galaxies and star systems and planets and coincidence. This one coincidence that happened here can happen in other places, and it can happen in a different way. While the science does not actually support it.
Well, I remember back in the 1980s, because I've been speaking on this now for more than 4 decades. I remember back in the 1980s telling audiences, eventually the evidence for fine tuning for the existence and operation of God will become so overwhelming, atheists will have nowhere else to go but to propose we're here by pure chance. But to make that work, they'll have to hypothesize there's an infinite number of universes where they're all different from one another, and we live in the one lucky universe where everything is just right. It's referred to here in America as the multiverse hypothesis. However, I appreciate the physicist Leonard Susskind. He's not a believer, but he says we atheists have got to stop using the multiverse. It's a bad argument.
Wow.
Now, what I've done in my book, The Creator and the Cosmos, fourth edition, is to give an illustration of why it's a bad argument. If you've
Hmm.
got an infinite number of universes where they're all different from one another, you'll have an infinite number of planets that are just like planet Earth. And
Hmm.
on that infinite number of planet Earths, you're going to have an infinite variety of birch trees. And birch trees peel white pieces of bark. And if you've got an infinite variety of birch tree species, one of those species will peel rectangular pieces of thin white bark that measure 8.5 by 11 inches. And these pieces will fall on random chemicals in the soil that will imprint on those pieces of birch bark all the paragraphs, diagrams, equations, and figures that you see in every scientific paper that's ever been published, which means that those papers did not come from the minds of scientists. The multiverse did it. And so you're basically exposing the philosophical fallacy. If you're going to appeal to the multiverse to eliminate God's design, it simultaneously eliminates all human design. And of course, no one believes that.
Yeah, because philosophically, you cannot have actual infinities, actually. This is where the whole
Well, that's
fallacy
another
comes from.
problem. That's independent of the problem I raised. So you've got two problems.
Yeah, so the very root of the issue of having actually infinite universes actually, to me at least, seems absurd. So wow, that was quite an exciting ride. Just for the audience, when I quoted the verse about the sun and the moon being two signs, actually al-layla wal-nahar ayatain, the day and the night are the two signs. And the other one that I quoted was the correct one, ash-shams wal-qamar bi-husban, the sun and the moon are with great calculation. And however, it all ties in what you have been mentioning for the
sure. I mean, you see it
in
in
the
first
night.
page of the Old Testament, where it says, let there be the great lights, referring to the sun, moon, and stars, and how those objects in the sky actually regulate the biological clocks. Notice you don't get animals until the sun, moon, and stars become visible in the sky, because microbes don't need to know where the sun, moon, and stars are in the sky, but all animal life does. All animals need to know that to regulate their biological clocks. So right on the very first page of the Old Testament, you got that statement.
Hugh, that was really an exciting, very exciting interview, as always. I'm sure many of those who watch this would like to read the books, but I will start from the Q&A. We have here Tony Maurice, actually, starting from end in mind. He says, Dr. Ross, would you say the multiverse is just the God substitute and escape mechanism for the atheist? But I think you have already addressed that.
So the answer is yes.
Yeah. So the fun part is that you predicted they're going to use it, and they did. So it's good. It's good
I actually predicted it 20 years before the argument was even raised.
Wow.
So.
Yeah. So I'm glad Leonard Susskind is honest. Actually, I like the guy. He's a string theorist, which who knows a lot about mathematics, and I think it needs somebody who knows a lot about mathematics to recognize that playing multiverse as a substitute for God doesn't make sense. But you've made it quite. Yeah.
Leonard has stopped calling himself an atheist. He's now saying he's kind of like an agnostic. And what I notice about Leonard, he's quite comfortable talking to people like us who believe in God. So I'm praying for the man.
Let me join you in the same prayer. Yeah. So I've actually watched so many lectures from him. I like the guy, actually. So
he's a good speaker. Yeah.
Very and a good lecturer, actually, too. So here's another question from Ziao. I hope I'm pronouncing that correctly. Levi's. He says, please ask this question of mine to Hugh Ross. How could an atheist trust their mind if it is a product of blind, naturalistic, unguided, mechanical process? Yeah, man, I think Dr. Lennox was actually making a comparable argument. So let's see what you have to say about this one.
Right. And it's an argument that's been developed by our staff philosopher, Kenneth Samples, basically making the point, if you're a naturalistic evolutionist, then you've got these random chemical and physical processes responsible for our brain, which means how can you trust your brain to give you reliable information if it indeed is simply the product of a random chance encounters? And therefore, we've got no basis, if you're coming from that worldview perspective, to trust what your mind is saying. It undermines the whole scientific enterprise. And this is going to be in a book I've just finished on dual revelation. how God reveals himself through two books, the book of Scripture and the book of nature, where I make the point. Notice that science came from a theistic worldview.
Yeah.
And the scientific revolution is not an accident. It's when people realize through their study of Scripture, hey, the laws of physics are constant, they're trustworthy, they're reliable. The universe is not capricious. It actually will reveal truth. This is what motivated the scientists in the scientific revolution to actually begin to do the research. Matter of fact, I've written a couple of books where I document the scientific method has its origins in the Old and New Testaments. And therefore, it's not an accident that the scientific revolution exploded out of Reformation Europe. It actually affected all three branches of the Christian church. And notice, science did have sparks within Hinduism and Buddhism and Confucianism. But in those cases, the sparks were still born. There was a brief flourish and then it disappeared. But what you see in the monotheistic religions, Judaism, Islam, and Christianity, is that there was an impetus that encouraged people to study nature, to learn truth about God. And so I tell my atheist friends, you're riding on the backs of giants. That's the foundation. But notice that that foundation is strictly theistic in its origin. And so you may be an atheist, but all of your scientific research is founded on a theistic perspective.
Quite depressing to them, I guess.
Well, hopefully it gets them thinking.
Yeah, hopefully.
I mean, that's one of the joys of my life. I've actually seen some of these scientists abandon their atheism and become Christians. So,
yeah, let's pray for that. Let's pray for that. Actually, this comment from Raihanul Soman is actually quite consistent with that. It says, planets, solar systems, galaxies, superclusters, it truly remind us how magnificent and powerful Allah is. Surely it will guide to those who honestly reflect. I guess so. How many of those have you seen? People who have actually eventually returned to God and abandoned atheism. Not just gone into agnosticism, but actually said, enough for that, it's not chance.
Well, there's two groups of individuals. There are those who were raised in a religious home, and because of some abuses that they saw, they abandoned their belief system, and then years later, they come back. Mm-hmm. And then there are people like myself who weren't raised in a religious background at all, but they begin looking at what they see in their science, and that's what motivates them to give their lives to the God of the universe. And I'm particularly passionate at reaching those folks, going to people who don't have a religious background and saying, look, it tells us in the Bible that everyone is without excuse because of how clearly God has revealed himself through the record of nature. And don't just look at one discipline. Look at all the disciplines of science. I mean, I love to talk to evolutionary biologists and say, don't just look at the genetics. Look at the physics of the sun. The physics of the sun is changing, and only a God that knows the future physics of the sun would know which life to remove from planet Earth and which new life to replace it with to compensate for the changing luminosity of the sun. Wow. Some random chemical process is going to quickly get out of sync with the changing physics of the sun, and you got the same problem with the changing physics of the moon and the changing physics of the Earth. But I find that a lot of them are really fascinated about that. Hey, I never really thought that solar astrophysics could have an impact on paleontology or genetics. And so just kind of helping them, put those pieces together. But another people group that I've been really interested in are scientists who call themselves atheists, but they're really default atheists. These are scientists that are very successful, but so successful that they just have nothing but fun doing their scientific research. But their scientific research is so fulfilling and so fun, it's all they ever think about. And I remember debating Peter Ward, a famous atheist paleontologist. And after the debate, I said, and you're over 50 years of age. Have you ever thought about the fact that you're going to die? He says,
Hmm.
"Oh, I'm just too involved in my scientific research."
Wow.
I said, "Well, what you see in the Bible is the principle of the Sabbath. We work 6 days and we set aside one day out of the week. And what that day is all about is stopping your regular work to focus on the most important issues of life."
Yeah.
And he admitted to me, he says, "I've never done that. I'm so consumed with my scientific research, I never take time out." He says, "Maybe I need to stop calling myself an atheist, because the truth of the matter is, I've never really thought about the subject." And I'm
Wow.
discovering there are a lot of scientists and engineers that are having such great fun in their careers, they never take the time to meditate about the most important issues of life. What is the purpose of the universe? What is my purpose? What's going to happen to me after I die? What's going to happen to my children? Are they going to find purpose and fulfillment in life? And what about when they die? These are issues every human being needs to think about, and we need to think about them on a regular basis. So that's
Wow.
why I'm a believer in the Sabbath.
Yeah. Yeah. Absolutely. And actually, by the way, in the Quran, the Sabbath is very underlined and emboldened as an essential habit uh, for
Well, that's
people
something
who,
I think Islam shares with Judaism and Christianity. All three
yeah,
religions really
yeah,
have that as a core doctrine, the doctrine of the Sabbath.
yeah. Except maybe in Islam, the day of taking yourself off work and focusing on prayer is Friday, and then we have the stop, the annual stop on Ramadan and the last 10 days.
Right,
Uh,
right.
yeah.
Well, I like
So
what Paul says in the New Testament. He says, the real principle is take one day at a seven. Says if you want to make it Thursday, Friday, Saturday, Sunday, whatever, the real core principle is take regular time out of your work week to
yeah,
focus on the most important issues of life. So,
absolutely,
and
absolutely.
I'm a pastor in a church, and I tell the pastors in our church, Sunday is not your Sabbath. Notice you're working throughout the entire
Ah.
day. You need to have a different day for a Sabbath.
Yeah. So the Sabbath is actually a concept. Maybe
It's a
this is
concept,
what it's
yes.
a concept.
Yeah.
Yeah. Yeah. Some actually have been looking into one verse of the Quran that talks about a village that was on the sea, and God blames them and He's punished them actually for not observing their Sabbath. The words are like this. Um, تأتيهم حيتانهم يوم سبتهم. Their fish comes to them in their day of Sabbath. ويوم لا يسبتون لا تأتيهم. And in the day which is not their Sabbath, it doesn't come. So it was a test for those guys that they work for the whole week, and on their Sabbath, they are a fishing village or a fishing city. On their Sabbath, he tests them that the fish comes on the Sabbath. And then the story goes on that they eventually twist the law and they do a trick. So they set up their fishing nets on the day before the Sabbath, and then when the fish comes on the Sabbath, it gets stuck in the nets. They cannot go back. And on the day following the Sabbath, they would collect the fish. And then people who believe tell them you're tricking God, and this is not how it works. He's obviously testing you, and what you should do is that you should persevere. And they don't listen, and they get severely punished. But yeah, so the thing is, every person and every group of people need to have their Sabbath, and it says something also about harmonized, having a harmonized day where everybody will, because if 90% or 80% of the people are working, they will push you into working because you're getting all those business calls. So yeah, quite insightful. So we have also a couple of questions only remaining. So we have Man's Man. So he says, so is it absolutely impossible for a livable planet to exist without a moon that had a magnetic core? This is
Yeah, because what I was sharing about would be a problem even for microbial life.
Mm-hmm.
So yeah, if you want to have even the simplest life on a planet, you're going to need to have a planet like the Earth, accompanied by a moon like our moon, with the identical formation history. It needs to form as a merger of two planets, so you get the necessary heat in the interior of both bodies. It's going to be important for the Earth to be super enriched with uranium and thorium, uh, and you're going to need the just right star. All that
Yeah.
needs to be in place to even get microbial life to exist on a planet.
And maybe the evidence for its importance is actually that we don't find life when those conditions are not there. And guess what? The conditions are not there except here. So
Right, right.
yeah. All right.
Well, there's an
So
important caveat. I've been on record again since the 1980s. We will find the remains of microbial life on virtually every solar system body for the simple reason Earth takes a number of big meteorite hits on a regular basis. And if you get a big enough meteorite striking the Earth, it causes Earth's soil to be
splatter.
blasted into the interstellar medium. And
Mm.
so, for example, we know that there's about 20,000 kilograms of Earth's soil on every 100 square kilometers of the moon's surface. And
Oh,
1 ton of Earth's soil has got 100 quadrillion microbes in it. So
whoa.
if we go to the moon, we're going to find the remains of Earth's life. And what excites me is Earth's geology has destroyed the fossils of Earth's first life. But the moon has almost no geological activity. We can go to the moon and we will find the fossils of Earth's first life and determine who got the original model right, the atheists or the theists. And I remember speaking about this at NASA and
Ah,
telling the scientists there we need to go back to the moon with a different mission to recover the remains, the fossils of Earth's first life. And everybody in America should be excited about this because last time I checked, 100% of the US taxpayers were made up of atheists and theists.
that's it. That's it. Okay, so this is the last one, I guess. It says, Dr. Ross, why do atheists invoke random chance when actual randomness doesn't exist? Isn't chance just a label to use when we don't know all the variables?
Yeah, that's a
So,
good comment. I think
mhm,
he's accurate making that point. An important caveat is that when atheist evolutionists speak about the randomness of natural selection, mutations, gene exchange, and epigenetics. They do point out some of those mechanisms are not always random. And so there's parts of our genome where things change in a non random way. But when you add it all up, there's no way that those uh, changes are going to happen fast enough. Because one of the things we notice about natural selection, mutations, gene exchange, and epigenetics, they're all slow change mechanisms that take a long time to produce any significant morphological difference. And when you look at events like the Cambrian explosion and the Avalon explosion, you see the instantaneous appearance, not just of one phylum of life, but multiple phyla. And if you're going to appeal to natural selection, gene exchange, and mutations, then you would anticipate that life is going to change through first the proliferation of species, which leads to the proliferation of genera, which leads to the proliferation of families, and then orders and classes, and last of all, phyla. But when you look at the fossil record, it's the exact opposite. You get the proliferation of phyla first and the proliferation of species at the end. And even atheist paleontologists like James Valentine in their book on the Cambrian explosion say this is the exact opposite of what a naturalistic model would predict. But it's the precise thing that you'd expect from a biblical creation perspective. It's something you see in Psalm 104. It's a property of all life to die off, but God recreates and renews the face of the earth. And so with the sun getting brighter and brighter, it's crucial that God remove life from planet Earth and replace it with new life that's more efficient on pulling greenhouse gases out of the atmosphere. And these mass extinction events followed by mass speciation events, they happen at exactly the right pace to perfectly compensate for the changing physics of the sun. Again, this has got to be the handiwork of a mind, a supernatural, super intelligent mind. Mindless naturalistic processes are not going to be able to know in advance the future physics and make the appropriate changes fast enough.
Let me close with this question of mine. What we have gone through from the cosmic crafting that God has done to your closing comments about life and speciation and mass extinction, etc. For any person who's honest to himself, there is a mind at work. What in your mind is the mechanism by which God is intervening? Which option do you find more relevant to your discoveries and your field of study?
Right. No, I'm convinced that the sudden simultaneous appearance of phyla of life, basic body plans, that happens by direct supernatural intervention. That the fact that it happens immediately when the oxygen reaches the minimum level to make animals possible, you immediately have animals. And you don't have them just in one phylum, you have them in multiple phyla. This to me can only be explained by the supernatural intervention of a God that's intent on packing the earth with as much life as possible, as diverse as possible, as rapidly as possible, to prepare the earth at the just right time for the entry of human beings. I mean, it tells us in the Bible we're the epitome of God's creation. We're the only species that's physical, soulish, and spiritual, and that God intends to use us, not just to have us redeemed from our sin and evil, but in the process to teach the righteous angels. I mean, the Apostle Paul talks about how these righteous angels are observing us human beings to learn about the grace of God. We get to experience the grace of God, they get to observe it, which is why Paul makes the point that when we enter the new creation, when God is done with his universe and takes us into a brand new creation, we'll be teaching and judging the angels. We get the privilege of being trained. Now, it also means we get to suffer. As it says in the Gospel of John, Jesus speaks and says, "In this world you'll have tribulation, but take heart, I've overcome the world." It's the tribulation that enables us to be trained and prepared for future careers in the new creation. And an analogy I think you'll enjoy. I've been both a professor and a student at universities. And as a professor, I tell my students, my job as a professor is to make you suffer. Suffer at just the right level so that you'll maximally be prepared for the future careers. And what you need to do is have a clear vision of how wonderful and enjoyable your future career will be. If you have that vision, you're going to enjoy the suffering I put you through. If you don't, you're going to hate that suffering and you're going to hate me. And I don't want you to hate me.
Very insightful, actually. Hugh, that was a very courageous answer, because many people who are entrenched in the scientific discipline will not mention supernatural intervention as a mechanism.
Well, what I find ironic, they're quite willing to concede that for the universe. They just don't want to concede it for life. And I think I know why. They're okay with the universe because they can keep God at an arm's length and not pay attention to him. But when you're talking about life, and particularly the creation of us human beings, suddenly God is intimate and personal, and he can be threatening to the way I'm living my life. So I think that explains why you get a strong reaction at that point, but you don't at the level of the universe.
Absolutely. Personally, I would definitely. That Islam teaches straight that Adam was, peace be upon him, was created directly by God.
Right, right.
That Eve was created from his rib, etc. And I don't see any reason why a scientist, be it a Muslim or a Christian scientist, would find it outrageous to say that God intervenes at different points since the Big Bang until today, and even every day. And I guess this is how prayers work. We pray to
Well, I
God
agree
for
with
things to
you.
happen. Yeah.
In the 21st century, I find it ironic that one of the big pushes towards reacting to that is coming from Christian and Islamic theologians. That's
Yeah.
one reason why I just finished this book on dual revelation. It's like we need to appeal to these theologians. You don't have to concede to Darwinism. The scientific evidence is not on the side of the atheist evolutionists. And
Wow.
so we need to shore up our theology.
I can't agree more with this. It's I find it really very depressing that so many um, Christians and unfortunately Muslims also have been affected by this. That they try to portray a modernist kind of facade for religion, and try to fit religion into the Darwinist stroke naturalist explanation of every single event that happens in the universe, even if it cannot be explained by by the universe. And
Right, right.
yeah, well, actually, even if you look at the level of quantum mechanics, etc., it just says that things are probabilistic, and um, God is actually engaged at the from my perspective, as somebody who's quantum mechanics is very close to my field of work, uh, God is engaged at the fundamental level of physics. He could be deciding what each and every particle, each and every electron and proton and quark will be collapsing in this state or that state in every single Planck length of time. Nothing prevents him from doing that, and he can magnify that to the macro level to the extent that things would take completely unprobabilistic path, whether it be at the end an improbable planet or an improbable creation of Adam. Nothing prevents God from that.
Well, Ahmed, I love quantum mechanics too. And I like pointing out to people if you don't have quantum mechanics, you can't have stable atoms and molecules. And you need that for life. So if
Yeah.
everything was deterministic, you couldn't have atoms and molecules. And even the uncertainty, the quantum uncertainty, must be fine tuned. And one story I tell, there's this famous astrophysicist who was at an international conference on cosmology, but there happened to be another conference on medical nutrition on the same campus, and he
Hmm.
walked into the wrong lecture room. But when he was sitting in the lecture room, he says, "I'm going to stay for this lecture," because he came out realizing unless the Heisenberg uncertainty is no less uncertain or more uncertain than it is, then there's at least four proteins in your physical body that operate like transistors.
Wow.
And if the quantum uncertainty isn't precisely fine tuned, those proteins will fail to operate, and every human being on planet Earth would die.
Wow.
Even the quantum uncertainty must be fine tuned.
Yeah.
So, and we see that in statistical mechanics too. If you don't have uncertainty in statistical mechanics, then certain motors inside the cell will fail to operate. So, the fact that God is even in control of the uncertainty, as Einstein would say, I don't think God plays dice. God does play dice, but he very carefully designs the dice to get exactly the outcomes he wants.
Wow. That is really that is really an insightful statement. I'll use that with your permission.
Sure, yeah, go for it.
Thanks a lot, Dr. Hugh Ross, for wow, what a ride! Great, insightful uh, dialogue from somebody who has grasp of both the fields of science and faith. I hope so many people will listen to this and get enlightened. And mostly to the fact that one can live his life believing that God is in control, but science is still useful and research progresses human beings, except that research can progress human beings into monsters or can progress them into good people. Science will not teach us to be good people, I guess.
Right.
Yeah, it will just teach us to be people who exploit nature rather than use nature for good. So I hope that many believers strengthen their faith by this dialogue, and that many people, like the ones you've described, those who don't take a break and think about what is really in their hands, because our lives are limited and we'll be here for only that much time.
Right.
So thanks a lot, Hugh,
Oh,
for
it's
your
been
time.
my pleasure. Thank you for giving me this platform. I appreciate it.
Same here, and please help me distribute your great knowledge to as much people as we can. And thank you very much. Thank you very much once
You're
more.
welcome.
And for everybody who has been with us, please do like the video and share it with as much people as you can, and share the science and the faith. And by the way, we'll be soon enough resuming the episodes for Dr. Hugh's colleague, Dr. Fazrana, to carry on with our Seeing God in Biology series, where we actually go into very interesting and mind-blowing facts about biochemistry and genetics and origin of life and debunking evolution, the Darwinist version of it. And thank you, Hugh, and may God bless your days and help us all be able to read his book of Revelation and his book of nature too.
Very good.
Thank you very much. Peace be upon you and everybody. Assalamu alaikum wa rahmatullah. We're putting the extra. Please wait for me for a couple of minutes to thank you after the show. And here we go.